So our next presenter is John Mailhot from Imagine Communications, and he's going to be talking about the NMOS device modeling project and giving us an overview and telling us about the progress so far. So take it away, John.
Okay, thanks, Wes. Mentioned, my name is John Mailhot, and I am a participant in the NMOS modeling project, or NMOS device modeling project. And more particularly, I like to think of it as the, how to finally make the universal standard-ish control protocol. And if that sounds like the Holy Grail, there is some history to people trying and failing to do this sort of thing, but I really believe we're at a point in the industry where it is finally possible for us to do some common work on device control. Now, we use the word modeling in the title, and so you might ask yourself, as I did, what are we modeling? And why do we use the word modeling in the project title? Well, if you think about a device, where by device, I just mean a thing that does stuff. I'm not using that word in any very specific way. Devices have some internal structure. Like if you had an audio mixer, you sit down at it, you can tell there's a bunch of things in there that are 32 copies of a fader bank, right? And then a bunch of other things. Every device has some internal structure, but it's different every device. That internal structure is composed of parts and subparts. Eventually, at the bottom of that pile, there's actually things that do stuff. There's a knob that sets a value. There's a fader that sets a level. There's the equivalents in video, RGB gain control, stuff like that. Many of those things at the bottom of the pile are actually common. How many faders are there? Some are logarithmic and some are linear, but there's not that many. The big idea of the NMOS modeling project is that we're going to provide a way to model the device from a control perspective. And by control, we really mean status, what are the values of the things that are read-only, setting, meaning setting values that can be set by a control system, and getting notifications and events, either status changes like the input cable fell off, or status changes like somebody else set this value and you should know because you're watching it. So if we succeed, or when we succeed, the idea is that common substructures, so something like a generic fader channel, could be exposed in a common API, and then that can be extended with vendor-specific stuff. So if my mixer has a bunch of extra controls in there, at least a controller that understands a generic mixer can see, oh, this is a fader channel, and I know what to do with that, even if it doesn't know what to do with the extra stuff. And this notion that a generic controller could find the generic parts and control them should be super powerful. I mean, that's the idea behind this activity, is that we're going to enable, control in some more organized way. Now, you might ask, well, NMOS has controls, right? Because we got ISO 5. And ISO 5 does connection management, and it is a perfectly good control method for one specific thing. But this is a much more generic challenge, which is how do we allow a device to represent its control plane in a standard-ish way. So why would this be useful? Like, why should anybody bother to do this, either as a controller vendor or as a device vendor? Well, it has to do with what customers are trying to achieve. As you heard the talk from ORF this morning, and pretty much any customer you talk to of any size, what they're trying to do in new builds is to have flexibility of the facility and some kind of agility of the devices inside. Now, as a device maker, we make devices that can do this or that or the other thing, depending on what you ask for. And they can be set up in flexible ways, but something inside the plant, inside that flexible media facility, has to be the controller and actually decide, for this show, I'm going to set up these things this way and organize it this way. And that control system, or that control environment that sets those things up, First off, you have to have one if you're going to actually get the flexibility and the agility. And second off, that control system's not magic and it's not free, and it takes work to develop and curate and maintain, and there's many vendors in the business of doing that. But if every control system has to write a custom driver for every device, then it will be a very difficult industry, because we'll be constantly supporting control system XYZ, trying to write a new driver for device W, and it just on and on. It's kind of an n squared set of costs that as an industry we frankly don't need. So maybe it's time as an industry to have a approach that at least lets straightforward things get done in straightforward ways. That's the idea. So you might think, well, haven't we tried this before? Haven't I heard this song before? And if you've been around the block long enough, you've run into SNMP. Now, SNMP is a great example of this succeeding, in that it had standard MIBs for standard things. So if you go to pretty much any Ethernet switch ever made by anybody, and you crawl it with an SNMP crawler, it'll find the standard MIB for an Ethernet interface for every interface and give you a nice, printout of all that. The shocking thing about SNMP is honestly that we're still using it in 2021. It's old as the hills, but it worked for the things that it had standard MIBs for. We still use it today because it works, because it actually had these standard MIBs that were, pretty well nailed down. Why didn't it work better? Well, partly adding new standard MIBs was a pretty arduous process. It was sort of like went through the IETF and took a long time to add a standard MIB. And so a lot of ideas for new MIBs that would have been standard kind of died on the vine because it's just hard to do. And there was no good way in SNMP to say, it's the standard Ethernet MIB, but with 3 extra things on the end. And to have a controller be able to recognize that it's the standard Ethernet MIB with some things I'm going to ignore at the end. And yet that's kind of the use pattern of the industry. So was the challenge, right, with SNMP. But even with the sort of narrow scope in which it succeeded, it's been very successful, right? We're still using it 30 years later, 40 years later, however long it's been. Now, OpenConfig for switches, it did a very similar thing to what we're trying to do. They had a more active process for creating new standard MIBs. And in fact, OpenConfig is pretty successful within its domain, which is to be, I'll say, a more modern version of SNMP that has notifications and things that work better. It is the modern successor to SNMP for switches and routers and so forth. And there are standard MIBs, and OpenConfig is pretty popular. Ember Plus, another control protocol that's been, is somewhat open. You can go to GitHub. There's an Ember Plus page. There's some code examples, a lot of nice stuff there. It has the idea of public schemas, meaning that there could be a schema that describes a subtree, and you could agree that several people are going to use the same schema. But those schemas aren't that common in practice. There's one successful one that I know of, which was something called Ember Plus Bests, basic endpoint streaming something. And it was used by a number of controllers and a number of devices, mainly in 2022-6, but also in the early days before NMOS really gelled up. Some devices implemented that, some controllers implemented that, and there's some fair amount of use in the field because it was a common subtree. And so it achieved some use. Now, the best example of this actually is AES 70, or OCA, as some people know it, which is pretty directly out of the audio world. It could be extended into video and into television production and so forth. And OCA is actively succeeding in the audio space. So we are learning from it. In fact, some of the OCA development, some of the people who are totally familiar with OCA are deeply involved in this activity. And the two are quite similar, and we're taking things that were learned during the OCA development, applying them here, and maybe some back as well. So there is a lot of overlap of ideas between this and that. All to say, what are we doing? So there's a thing called the NMOS control architecture. You'll notice at the bottom of the slide, there's a URL, and that's where this work is. And if you want to follow along, you could go there, and there's documents and trees, and that's where the repo is. So fundamentally, we modeled the device with a set of class definitions. And so there's classes for basic items, sensors, meters, controls, all that. There's also some housekeeping classes, a root class, so forth. The idea is these classes can be extended in a normal object-oriented design philosophy with inheritance rules, and it's nothing unusual for people who do this for a living. This is pretty standard methodology. We have a modeling language. We use WebIDL to describe the classes, which again is a sort of modern choice. And one of those classes is a container, a structuring kind of class that we call NCA block. It's kind of an arbitrary name. But you can see you could have like a linear control that inherits from NCA single control, inherits from NCA actuator, inherits from NCA worker, eventually inherits from NCA root. That's the little chart on the right. And that's very standard class object modeling stuff. But how does it relate to a device? Well, in a device, you would have instances of those classes associated with each of the things. And then they're organized in blocks in a structure, and that's how it works. So in fact, this is our beginning of our class tree with the root class at the top that has all the generic stuff, and then all the other class definitions inherit from it. And again, standard stuff. Now, the big idea, number 2 in here, is about these containers, these NCA blocks, because you wouldn't want to have a class definition for every single set of things in the world. That would create a bazillion classes and really not add a lot of value in there. So the typical use pattern is that NCA block is a container class, and it has a set of named items in it. And those named items can be objects, instances of some class, or they can be blocks that are in fact containers, and on you go. And that these blocks will have schemas. So the schema is sort of the list of what you expect in this block. Those schemas are what's actually standardized, in addition to the basic classes. So this way, if you're tracing down the block tree, you can find a block that implements, standard fader. And you say, I know what to do with one of those. You could find a block that implements fancy fader and it also implements standard fader. They're scoped. And of course, you could find a block that implements, imagine proprietary thing, but also implements, say, standard frame sync. And then okay, I can at least control the controllable parts of that. This whole mechanism is designed so that you can express what is common and also extend it with the vendor specific parts where it makes sense. That's the idea. Now, big idea number 3 is that in these blocks, there's also signal path details. So in addition, what's problematic is if you get from the control API, you get a pile of knobs, and you get a pile of senders and receivers and ways signals came in and out. If you don't have the map of how those things relate to each other, then you're in deep trouble. As a controller, you're not going to make a lot of sense out of it, or you're going to require somebody during setup of the show to go explicitly saying this signal is going to here and this signal is going to here, and doing all the plumbing work that you would expect the device to do for you. So in our definitions, the blocks have ports, and the ports have, these little linkages. So a block has links, ways you can connect to the stuff outside the block or above the block. And also you can describe how things are connected inside. So basically you can indicate in the block how the knobs and functional controls relate to the signals. This way, the control system can read that and know, okay, this is the fader for that thing, it lets you expose, as a device, it lets you expose the basic information about how the knobs relate to the signals. If you don't have that, then you're going to have to implement that in every control system separately, and that's a bit of a pain. So those are the big ideas of NMOS modeling. Now, how would this actually help anybody? Well, the device model, like we said, it provides this structured view that lets you expose the controls and the statuses of the things in the device so that the control system can expose those eventually to the user, or the control system can take actions based on them. Of course, they're exposed through a protocol, and we are deliberately defining the modeling system separate from the protocol that carries it, because there might be different protocols over time. And it's just a design philosophy thing to keep those ideas separate. But the protocol will allow the controller to walk the tree and see what's there and see it in pretty good detail, like to really query it, or walk, like you could walk an SNMP MIB, you could walk this thing. The controller can subscribe to notifications, particularly value change notifications. So if you have, say, multiple controllers, which is pretty common, if one controller goes and changes a value and the other one's subscribed to the notification, then guess what? It knows. And so it can move its knob to match your knob. All the cool things that you expect to work in a system can be made to work. You can, of course, as a controller, make changes to the parts of the model that are writable. You could track changes made by other controllers, the things you need to do to make the control system work. And then, of course, the key really is this idea that there's going to be standard public schemas for pretty standard functions, but then you can make proprietary extensions to them. And that way the controller can at least recognize the standard parts, maybe map those to standard control arrays or gang them in standard ways. But a sufficiently detailed controller could go climb through the proprietary parts if you want to let it. There's also a security aspect to this, and ways to say, both to secure the protocol as a protocol layer thing, but there's also likely some permissioning to be done about which controls and which authorization of the connection and so forth. We're cognizant that that's a requirement through the basic development of the scheme. That's not like we're going to add security later. We're keeping that in mind as we go. So that's sort of the nutshell of it. Now, what's the state of play? How's it going? Well, there is a working group that meets every Tuesday. The posted spec, you see the URL at the bottom of the page. It lags our work by a couple of weeks because our work is, we're doing the work live, and then occasionally there's a pull request that puts it out into the GitHub repo, and that's what the public page is, a render of what's been sort of locked in. So the public face is a couple weeks behind our current discussion, but that's okay. The more participants are welcome. That's probably, I can't say that hard enough, that's there's a good smattering of people involved, and they cover both control vendors and equipment vendors and broadcasters and developers, and we have a reasonable mix of people, but we could always use some more ideas. Our next goal is to have a workshop, probably a virtual workshop, because that's the beautiful thing. These things can be done over VPNs very easily. So we're shooting for a virtual workshop sometime, over the course of the remainder of the year. We'll probably use a JSON RPC protocol over WebSockets as our base protocol. Not to say that's the decision for all time, for all purposes, but that's what we'll start with because it's a simple and well-known technology. And the first blocks and schemas we're focusing on are really the ones that relate to NMOS senders and receivers, because that's an interesting example of ISO 5 tells you how to make a connection, but it doesn't tell you how to find out if the connection is getting data, right? And you'd think that would be useful. So that's one of the early items we're looking to have, standard items for, is how do I status that the receiver is actually getting a signal, for example. So there's a number of other schemas that we'll probably, check out along the way, just in terms of depending on which devices actually implement this for the workshop, they'll probably take some stabs at exposing their base, their base operations a little. Now, it wouldn't be a talk about an AMWA thing without mentioning that you could help. So joining the AMWA, it's not free, but it's not super expensive. And there's university rates and there's individual consultant rates and all kinds of things. Many of you work in companies that are members of the AMWA, which means that you could just turn up to a meeting. But the key is really not just to join and lurk, because that happens. Another group I'm in, the SNMP 2110 drafting group, there's, last I checked, 189 members of the group, and only about 20 turn up to the meetings, and that's good. I'm glad for those 20. But this group, please, if you're going to come join it, participate, which means actually learning, following, and understanding and participating in the conversation, because we're making interesting choices. Be ready to dive in and do some work, because the interop that we want to have later in the year will only happen if a couple of vendors and one or two control vendors actually implement this thing, or the proto of this thing. And of course, the other reason for participation is to bring perspectives to the discussion, to bring different ways of looking at it. And that's really the key to all this. So that's how you can help, and look forward to more people joining the group. Did any questions roll in, or would you like to make one up?
No, I've got one here. Let's see. Oh, wait a second. Sorry, that was a private message. So it says, hope, Imagine, Arista, Sony, and SNMP product models will be using IPv6 to allow for these port flexibility. What do you think about that, John?
That sounds like a leftover from Gerard's talk. I'm not sure it's germane to this at all. This modeling probably is orthogonal to whether we're using IPv4 or v6.
Yeah, I think you're right. Yeah, I mean, I think so. I mean, you're really modeling functionality, and that's going to be a much higher layer than whatever the IP transport is going to be.
Right, and the I mean, like the 2110 spec is independent of v4 or v6. The AMWA ISO 4 and 5 are meant to be independent of 4 or 6, but I hope we achieve that. I'm not sure I've seen anyone try it for real with IPv6 yet, and that would be the proof point. But yeah, this modeling is more about the functional dissection of the product into its native organization pattern, and then representing that out of a an API.
So John, do you think this will end up being like SNMP, where you have public and private MIBs? Do you think there'll be a lot of private stuff going on in here?
If it's successful, yes. And the thing we're trying to learn from SNMP and do differently is really how the public and private relate.
Okay.
Because in SNMP, it was like a very high level switch that you would it's either public or it's private. There was no intermixing hardly. And here it's more about, you can have a branch that implements a public thing with some private parts tacked on the end. And so that way, at least the public part, what to do with, and the private part, you could guess from the names, but it would be guessing.
Mm-hmm.
Now, somebody brought up, is there any sort of featured GUI available? Well, this is really about the modeling of the device and the protocol by which it exposes its interface. The actual development of UIs that would connect to that's a whole nother matter. We're not at all describing user interface, user experience. The goal of this project is to make the status and parameters and alarms of devices be available to the controller. How the control system exposes that to users is a whole different business.
So do you see this evolving, and so you're doing the modeling. Do you see this evolving into things that's more, control oriented, or maybe even media aware, so you can do things like, um, you know, switch a program or insert an ad and things like that? Do you see the
Yeah,
model supporting a time base for all that?
well, I think the control protocols definitely expose, controls that are operational, right? So gain controls and faders and cut and, so at some point, like on the master control panel, there's a take button that you wait with your finger near it until it's the right time to drop the ad pod, and then you go bang. And this protocol is absolutely meant to take that button and convey it to the device. So yes, the media controls are controls, and they could go through here. As for whether there's a content breakpoint awareness in the protocol, there's not yet, but if that's, that's sort of a plane that we haven't actually discussed that thoroughly yet. So this is a work in progress, and our goal is to make it meet the needs of the industry. So if there's, if content trigger awareness is somehow important in this aspect of the model, then that's something that certainly a control would do it. Now, somebody asked if there's provisions for speccing do this operation at this time. It certainly is there's an aspect for that. As opposed to having it be a live knob, you can have a timed actuator that's set up that says do this later or do this at a certain time in the future. At least that's in the that's deeply in OCA. They have that, and we're likely to inherit that feature.
Cool. There's another question that came in before that said, what kind of protocol is planned to be developed? I guess getting some structured properties from devices is not a problem, but what about changing them? Any separation between read-only and read-write properties parts of device descriptions?
Well, yeah, I mean, there's control and there's status, and both are in there. So yes, the objects would include, read onlys, statuses, and also read writes, controls. So because they're both real, you have to support both.
Okay, cool. So I'll just ask a kind of left field question. What do you think is the future of SNMP in the media industry? Is it gonna just be there forever, or do you think it's going to slowly grind to a halt? What do you think?
I think the fact that it's still there today is because nothing has replaced it. And so it'll stay until something replaces it. And that thing that's going to replace it has to have at least as much utility, hopefully more, and have ideally a modern security model and a authorization and user rights model, and all the things that are sort of modern requirements. I mean, SNMP had no security until really version 3. I mean, there's sort of the joke password in there, but forget that. And then SNMP still doesn't have a particularly concept of user rights management of, this SNMP controller is allowed to manipulate this, but not that. There's a little bit of that, but it's not very deep.
So are you including users as inside this model? Are they considered to be part of the model for at least for rights and things like that?
Conceptually, yes. I mean, you remember that we're at we're in like the beginning of an early phase of this. So security is a bullet point, and role-based authorization is a bullet point, and we understand that both of those are requirements of real systems. Now, how end users translate into roles on specific equipment, some of that is really a control system issue, and some of that is actually a device issue. The device doesn't necessarily have to know that there's 20 different users and their names are Joe and Fred and Steve and Bob, but the device has to know that there's operators A and operator B, and that they have different roles.